All right, we're going to talk about continuity. So we say that a function f of x is continuous at a particular point, and our particular point we are referring to as x equals c. So c is our x value of interest. So it's going to be continuous if we have three things in place here. So one, we need to have the limit as x approaches c from the left. That has to equal the limit as x approaches c from the right. So that means the overall two-sided limit as you approach c from each side has to exist, right? It has to be the same value. Remember, that's the only way it does exist. It has to be that same number. Well, the two-sided limit has to be the same as the y value, which we call f of c. Okay, so this is the y value. So a quick illustration here, you have a function f of x. Here is our point of interest. C is the x value. The y value is f of c. So we can see here that the y value is f of c. And as you approach c from each direction, notice how the limit value equals the function value. So again, what we have up above here can be shortened to just this right here. The overall limit as x approaches c has to equal the function value. Sorry, this should be a c. Okay, so the overall limit must equal the function value f of c. If that's the case, we say the function is continuous at that point. Okay, quick definition here. Throughout this course, you will hear the phrase continuous function over and over. So let's make sure we have an understanding of what a continuous function is. So a continuous function is simply a function that is continuous over every point in its domain. Okay, so if a function is not continuous, then we say it's discontinuous. And a lot of times we will see functions that are discontinuous at certain points. So the first type of discontinuity to be aware of is a hole. Now we further classify our discontinuities as either removable or non-removable. We'll talk about non-removable in a few moments. But first, a hole is the only type of discontinuity that is removable. And here's how you can remember it. Think of it as we can remove the common factor. Recall that holes are created from common factors. Let's jot that down as a reminder. So holes are created by common factors. Recall how we canceled out the common factors. So a hole is a removable discontinuity. Think of it as you're removing the common factor. Okay, next one. So our next type of discontinuity is when we have a vertical asymptote. So this is known as an infinite discontinuity. Think of it as you get closer and closer to it, it goes up or it goes down all the way to either infinity or negative infinity. So it's an infinite discontinuity. You can see that it's not continuous. And we also say that this is a non-removable discontinuity. So again, the idea is that there's no common factor to remove. So in this particular case, just to be a little more specific, we know it is not continuous because the function value does not exist at that VA. Remember, for a function to be continuous, the limit value had to equal the function value. Okay, our third type of discontinuity is known as a jump discontinuity. Sometimes it's called a step. So it's exactly what it sounds like. You can see that it's a jump down or a step down. This is another type of non-removable discontinuity. And this is not continuous because the limit does not exist at that point.